about and be using in Lab 2, that will be explicit conversions. This right here is a simple cast. So another example, the next slide. We have double number 1 equals 4.25, and then float number 2 equaling casting to float number 1. So similar to the implicit conversion where we don't have the parentheses in float, in this we are intentionally casting to the float. Primary difference that we'll see actually in Visual Studio is if you implicitly convert, you'll more than likely get a warning, not an error. If you explicitly cast, you should not get the warning. And then also very important to note is, this will be important later on in a separate lab, and I'll try and make a portion of each demo to remind people of this, is characters and ints, for the most part, can cast or implicitly cast to one another. A capital A has a numeric value of 65, capital B 66, capital C 67, so on and so forth. I believe 0 through 255 is the castable range of numeric values for character values. They range from English alphabet, A through Z capitals, lowercase. It might include some special characters, like characters with accent symbols, different operators, and maybe some emojis. So go ahead and play around with it just to get used to it. But again, capital A has a numeric value of 65, so the value that would be stored after casting this letter to an int, number 1 would have a value of 65. And if we were to do that in reverse, so we had a number 66, and we were passing it to a character, that character would be capital B. So when we're talking about parsing or explicitly converting, in this language, we have shortened method names. So we see STOI, that stands for string to int. So right here, we have a string identified as number 1. It equals the string literal value of the numeric 5, not the word 5. And then on the next line, we have int number 2 equaling this method call, so string to int. And inside of the parentheses, we have the variable or the value that we're going to attempt to convert using this method. So in this case, we have number 1. If we didn't want to use the number 1 and we just wanted to use the literal value right here, we could put this literal value right here. Very important to note about these methods, because there's one for basically each different type, is it forces the conversion. It does not attempt a conversion. So if the value of this number 1 was not a numeric 5 or numeric 1 or any other number, and say it said Bob does not convert to a number, you would get a runtime error. And we'll see that as part of the live demo. And then for the actual definition of parsing, in C++ refers to the process of analyzing a sequence of characters, typically stored as a string, and interpreting its structure according to specific grammar or syntax rules. It involves breaking down the input into meaningful components or tokens, validating the arrangement, and extracting relevant information. A lot of fancy terminology for trying to force a conversion from a string to whatever type it happens to be. So in this case, it's string to int. So right here, we have string to float. We have string number 1 equals 5.25, again the numeric versions, not the words. And then we have float number 2 equals the string to float method, passing in inside of the parentheses the thing that we're trying to convert from a string to a float. So up until this point, we should be very familiar with C++ primitive data types, so the int, float, long, double string, etc. How to identify syntax errors, how to use the Visual Studio debugger, basic C++ debugging techniques, the difference between explicit and implicit conversion, the proper syntax of a C-type cast, how to use the string to method, that we didn't cover yet, I'll cover it here in a minute. Methods to parse strings into valid number values, or I'm sorry, we did, I'm thinking of different methods. So string to end, string to float, string to double, things like that. And then at this point, you should be, at least when we get to the lab portion of lecture or lecture lab. Completing the lab 1 assignment if you haven't already, reviewing 1.02 and 1.04 research assignments on episode, following along with the program demonstration, which we'll probably get to at the end of the slides. I'm assuming this is one of the last slides. And then within the research and continuing to expand on the demonstration as a self-exploration or experimentation environment to get a better understanding of the concepts, and then eventually leading to lab 2 assignment. Do we have any questions on any of this so far?
Outro slider.
All right. So while I'm getting up the Visual Studio setup, feel free to throw any questions at me, and we will continue on momentarily. Question from online is, should we try Visual Studio with you? That is my recommendation, is you try to follow along. If you feel that I'm going too fast, go ahead and type something out, or just open your mic and say, hey, can you slow down? I'll pause it for a moment so everyone can catch up. So what I'm going to do is open Visual Studio, click New Project. We're going to open up a C++ console app. Make sure that it says C++ either via the icon or over here, and then it says console app, not empty app, not Windows app, console app. Double click it or click next. Go ahead and name your application. In this case, I'm going to call it DT Demo. And we are going to get rid of all of the comments that come with the default project. And to start out, we're going to include string, then put some comments. And what I basically like to do when we get to the later on live demos is I'll take a few minutes and I'll put a comment for each section that I'm planning on covering. And then as I think of them throughout actually doing the live demo, I may rearrange them, I might add some to them. So it may take me a minute while I'm thinking of basically what's accurate. First, we are going to go over types with size and range, operators, arithmetic, and spell down this one now. And then the differing assignment operators. Math the long way.
Math the long way.
Math the short way.
Math the short way. Let's come back to that.
So the comments that I'm writing, the question is, don't need to copy the comments. I still would, because I'm using them as headers to kind of organize my thought process when I actually type out code. There's going to be a bit of an explanation, but if you don't want to type them all out, this is, of course, going to end up on the PG1 announcements channel, so if you just want to go through the code and some of the comments, that's perfectly fine. I would just recommend downloading my version of it off of Discord at the end of the day, so you have the in-depth explanation comments. Right, so we have the operators, the types, the different sum operators, errors, and then, let's see, I'm going through the slides real quick. Anything that I want to specifically show, debugging. Debugging, scripts. Here. Question from online for what I'm typing right here is, I'm going to put that at the very beginning, right now actually. Double slash is a single line comment. Slash asterisk is the beginning of a multi-line comment. This a slash asterisk is the end of a comment, multi-line comment. And then cell guide notations. Two bytes. See the ranges already. I have that in there. Have operators, and I think we are good to start. Okay. So our first note, besides the one that I just made for the comments, is going to be the types with ranges. So what I'm going to do first is I'm going to basically be copying this verbatim, so I don't have the range memorized. No point memorizing them. Just need to know big, small, etc. for now. So we're going to go to Google or your search engine of choice, and we're going to say C++ data types and value ranges. We can skip over the AI generated stuff, go for Geeks for Geeks, and then we can basically pay attention to the first two columns here, where we have our data type and then our range. So we have car, unsigned car, short int, unsigned short int, so on and so forth, until we, there we go, actually that's actually perfect. So after Googling that and going to the Geeks for Geeks, so you know how to get to it, what I'm going to do is I'm going to drag this tab over to my laptop, and then I'm going to copy basically verbatim those columns for everyone to have in this demo. And I'm also going to put a note that we don't really have to worry about some of these. I'm going to put that in actually so it doesn't mess up the formatting. Also, I do have a little bit of an issue with spreadsheets that aren't color-coded, so I may go back and change the values because I read one line and not the other line. So just bear with me real quick. Let's see. To be remembered. And some of these, like the long int, there are special use cases for them. I'm not going to note for that. What's up? Make sure you extract it. Right click. Let me open up Farlight. I always get Windows 11, Windows 10 confused. So this is Windows 11, zip folder, right click, extract all. And for the online students who didn't hear the question, it's how to open a lab once you download it. At this point, with float is when numbers become so insanely large that they are they're just shortened to the mathematical expression for what they are. Okay, moving on to that after having those notes. In this day and age, especially for this course, you don't really have to worry about what type we're using. It's a good habit to get to get used to using a proper type for whatever you're trying to store. So if I were to give an example of a US phone number, there are multiple different ways to display a phone number. The way you were probably most used to seeing is parentheses, area code, parentheses, first three dash, last four. That's not a numeric type because it has parentheses and a dash in it. So if you wanted to display that way, you would have to store it as a string. If you wanted just the numeric version of it, that's 7 digits, so I think we're in the millions without like actually really thinking about it. So we could store it as an int, not a short. We could also store it as an unsigned int because phone numbers aren't negative. if we wanted to store coordinates, like if you were using a GPS and you were like doing like some outdoors excursion, like hiking in the woods or whatever, going like climbing mountains, and you needed to know like your coordinates for whatever reason. Coordinates are often a high precision digit, so we would probably be talking about a double and not a whole number, because if you just get the whole number version of a coordinate, you're probably approximately close, but not exact. Social security number for U.S. citizens is what, 3-2-4. So 3 digits, 2 digits, or 4 digits. Again, typically displayed with dashes. If you were storing it for whatever reason, it would be as a string. If you get rid of the dashes, or like if you're like you sign up for a new phone service or a bank account, they typically ask you for your last 4 sometimes. Those last 4 could be stored as a short, because it's 4 digits opposed to 5 digits that a short's maximum would be. If you're doing something with data science, the way like I can't really think of a real world example, except maybe like I'll say this thing as a real world example off the top of my head right now for flow. Maybe chemistry, if you're working with like such fine-tuned numbers and you're trying to store it and like calculate like something within chemistry, you might be using the flow. But these are important to know later on in the real world, along with my example of the Magic Arena game, where when somebody gained enough life, they broke past the limit of the type and it started displaying as the negative version of the type. Question from online is, yes, this file will be online on Discord in the PG1 announcements channel. I would recommend grabbing it if you are not going to type out all the notes like I have here. All right, for math operators, we have everything that we're used to. So we have addition, subtraction, multiplication, division, and mod. This is the one you are probably not used to seeing. What mod or the percent sign does is it gets the remainder of a division problem, not the quotient. I.e., we have 9 divided by 4. The quotient, would be 2. The remainder would be 1. Regular division will never display the remainder, only the quotient. It displays not a good word here. Get is another one. Differing assignment operators is going to be plus equals, minus equals, so subtract equals. There's multiply equals, divide equals, and mod equals. There are different forms of the assignment operator that may be useful to shorthand some math. So math the long way, as I put in on the whiteboard and in the chat comments. You are probably used to seeing math like this. When in programming, it is result equals formula or equation. So it would end up being 4 equals 2 plus 2 here. Also a note on self-reference. Int x equals 3. In real world math, at least I haven't seen this, but I'm not a math person. The example of x equals x plus 2, where the x left or right of the assignment operator is self-referencing the old value, in this case, 3. What that breaks down to is new x equals old x plus 2. How that looks with the assignment operators, the new assignment operators, is down here. Or x minus equals 3. So it's the same as x equals x minus 3, or x times equals 5. It's the same as x equals x times 5, or x divided equals 3. So it's the same as x equals x divided by 3, or x mod equals 2. This is the same as x equals x mod 2. If you have any questions on the assignment operators or any of the types so far before I continue? All right, moving on to the style guides and notations. So style guides are going to be small documents that dictate how your project can and will be written. For the most part, we don't go into other aspects besides the notations like camel case or Pascal case. So for camel case is where the first letter of the first word of your variable name / identifier is going to be lowercase when every other word, or every word after, sorry, so every word after the first character is capitalized. This is a style guide thing that will let us know immediately that whatever we are looking at should be a variable. Next is going to be Pascal case. This is where the first character of every word in a variable name / identifier is going to be uppercase. This denotes class names, method / procedure / function names. So when we look at something that is written in Pascal case, we know it should not be a variable. We have any question on casing? All right, moving on to syntax errors. So syntax errors are going to be errors that actually appear in the error list of Visual Studio or whatever compiler you have to be using for whatever language you're using. And it also, more often than not, I think this is going to be basically true for every language, it's going to be denoted by a little red squiggle under the code that you have written. So syntax errors are denoted with the red squiggle under a line of code or appear in the error list of your IDE, Visual Studio, and the error list by default appears in the bottom left-hand corner of Visual Studio. You do not currently see it now. It would appear right here where my mouse is circling, where it says no issues found. If there was an error, like if I type in, we get an error here where it says identifier name is undefined. What this means is that I tried to output a variable I have not created. The machine is not going to be smart enough to create it for me, and most of the time will not suggest suggest making it. It will simply say the error that I have above. There are many types of syntax errors, and you may not see all of them for years to come, but they will always appear with the red squiggle or in the error list. Next type is going to be runtime errors. So that's basically where your game crashes, your program crashes due to an outside factor normally. I'm going to create one after I get that type out. So a runtime error So that last little bit is typically you'll see a Windows panel pop up detailing the crash, but not always. Most of the time, however, what's going to happen is Visual Studio will jump to some library where what you were attempting was using the code from that library, and what you wrote does not work. So the crash will typically say something along the lines, this is in layman's terms, not exactly, hey, whatever you're doing does not work what you were trying to do, and it will basically say why and show the code from the library, and the code from the library is an alien, and it's not going to be very helpful at this point in time. It may be helpful to you later on, but the context, I'm going to put this here in notes in a minute, the context that you should get is when you're running your application, you should have a mental note of where the application is in the code. And what I mean by that is, like, say we have 5 lines, and it's asking the user for their name, asking the user for their age, and then you try to do some math with their age without converting it. Because every time that you take stuff from the console, anytime you take stuff from the user, it always comes back as a string, and you just can't do math with strings. It may concatenate, but it probably won't if you're trying to do a math equation with it, and that's going to result in runtime. So we just have a mental note of where the program was in the code during the crash. And in that case, it's going to crash when we try to add the string and the number. So wherever we attempt to do that in the code, that's where we should look.
Okay, write that down. What's next? We need to finish this lecture so we can focus on 3, and then focus on 4, and then maybe upload 4 or lab 4, and probably the practical, and then focus on the week that is the current.
Okay, so an example of runtime error, hopefully recreating this. So we're going to create a string and another string with the same name. Okay, so this is going to be a good example. We have 2 variables of the same name. In C++, this looks good, but isn't. And one of 2 things is going to happen here. Either we'll compile and get a runtime error when we hit that line, or we'll actually get a syntax error that wasn't caught during automatic build of the project. And what automatic build is, in some modern languages, like C#, when you type, you won't see anything happen. But the project builds, so you do not have to go through the manual process of going to the build menu option and rebuilding. Question from online is just a general review. It's a review of the concepts that we went over during lecture and some extra stuff. Moving on, we're going to attempt this, and while I'm thinking about it, I'm thinking it's not going to compile, so this is actually an example of a syntax error, and if that is true, which it is, we're going to do the example of asking for their age and trying to do some math to it. So, we will comment this out, and then we're going to prompt the user for their age. We're going to set up a variable for their age.
What's he doing right now? Command output,
we are
string,
actually remember that. I type that thinking about send, but it's a statement.
end of output, inline, statement, recruit, string, name, user, age.
Paste in that comment that I wrote previously, and then
so that you could see another next line. User age.
okay. So here we're still getting a syntax error. So my next example, which I know 100% is going to work, is we're going to force the conversion. So we're going to comment that out, just this line.
Okay. I see he's trying to add 2 to whatever their actual age is. Or whatever age or number they input. Okay.
And then after making our int, we're going to say converted age equals standard library, stoi or string to int, and user age. Now, no errors, except for something that I probably have to clean from here. We get the name redefinition. So that's kind of what I mean by where I talk about the automatic rebuilding. We're getting the error of name redefinition, multiple initialization, where I have string name and string name. It's commented out, but the language does not do a very good job of rebuilding itself. So more often than not, you'll find yourself doing this where you go to build and rebuild. And then pay close attention to the bottom of the screen where the error list is. After I do that, error list goes away. So the language just doesn't do a good job of cleaning itself. So now, I'm going to run this a few times to kind of show the runtime error. So first time is, we're going to run the application as intended, where we ask the user for their age, we're going to type in an actual number. We type in a number that can be converted, so it works. No runtime error. However, please enter your age. In this case, you saw Visual Studio jump somewhere. We do not have a Windows pane, and it didn't actually change the active window to Visual Studio. So, unhandled exception at that memory location, so it's a hexadecimal thing, in the day2demo.exe, which is a Windows executable file. Microsoft C++ exception, standard library, invalid argument of memory location with memory location. So a bunch of garbage that doesn't really mean anything to us right now. We just know contextually, hey, the last thing I did is I tried to force a conversion, and the user didn't type in a number. So, like what we're talking about in the slides, this forces a conversion. It's either yes, it happens, or no, it errors. So this is a form of runtime error because the user typed in something that was not convertible. Same thing, if we close this out, please enter your age, and they type in just a letter, even though a letter can be cast to an int. In this case, we are using the string to int variable, or I'm sorry, not variable, but method, to force the conversion of that string to that number. And in this case, we're using strings, not characters. It doesn't work. So that is an example of a runtime error.
Let's see. End of runtime.
Just a note on that is the line is good. It just depends on what you type in when you test the application. String to end, string to double, string to unsigned long. Any of these string 2 methods, because there's a bunch more, force a conversion. We're not error handling. We're not data validating. So we're not going through the process of forcing the user to type in something that we say. And there's things that we can do that will end up doing that. So real world example is you sign up for whatever social media, and it's asking for your email. A very base data validation for an email is if the @ symbol does not exist in that text field, someone will be like, hey, that's not a valid email address, type a valid email address. That's kind of what we're talking about here. But these methods do not automatically do that. That is something that we as programmers have to account for and make ourselves. So when we're testing out these methods, which we're using most of them in Lab 2, make sure that the value is when you're not in Lab 2, because I'll explain a little bit better when we get to Lab 2, we provide the values, but when you're testing this out in your own examples, like in this, if you download this or you're writing this along with me, that when you're testing this, you're typing in an actual number, like a numeric value, not a word, not a name, not the word 1, not the word 2, etc., a numeric value. And then, going on from there, we have logic errors. Logic errors do not produce an actual error, i.e. syntax error or runtime error that crashes the project program. These are lines of code that are of correct syntax. They 100% run, but do not yield expected results. The easiest to replicate right now, without going into other days' material, is essentially mislabeling variable names, i.e., we prompt for a first name, and we store it in a variable named last name. And we can do the same thing for their last name into the first name variable. So, like I said above in the notes, the above code does work. So the creation of last name, first name, prompting, and storing into the purposeful long variable contextually for what we're asking for. And when we go to output it, if we're not thinking about it, again, very basic logic error, it's easier to see them in day 4 and beyond, just because of the type of stuff that we're doing in those days. But if we go to run this now, so we're at the portion of the code where we're entering our age, enter your first name, enter your last name, and then our output of first name is my last name, and then the displayed last name variable happens to contain my first name. So again, very basic logic error, very simple to fix. Sometimes logic errors are not so simple to fix. Just really depends on the project and what you're doing. But just know that when you are getting output or data that does not look right, it is probably going to be a logic error. It is 3:16. I went a little bit past an hour. Why don't we go ahead and take a 10? Go ahead and be back at 3:27. I'm going to pause the recording, but I'll still be around to answer any questions, so feel free. We have debugging and breakpoints. So, debugging is the process of fixing your code, i.e. bug hunting, and retesting, essentially. So think write code, eventual bugs. You have to find the bugs and remove and /fix them.
Last page.
Breakpoints are a tool available to you in most IDEs, including Visual Studio. You click to the left of the code. If you have line numbers enabled, it is going to be to the left of them. So what I'm going to do is I'm going to write a line of code real quick, int x equals 3. And then we click. Now right there, it says the breakpoint will not currently be hit. The source code is different from the original version. The reason why we were getting this error is because I left the project running. I did not stop. So we stop it, and we can see that the breakpoint became filled in. Again, the reason was because I put a breakpoint in while the application was running, so that breakpoint would just never be hit on that current running version. Now, when I go to run it, let's see, we're at enter our age. And now that should have been the last displayable line, or the last thing that we see, but because we have the breakpoint, we're going to see the cursor. Now, if I put a breakpoint on, let's say, right here, we go to run this, we type in 34, we can now actually see the program has halted. We know there are more lines to go and actually display and execute. And if we open up our command prompt or our terminal, we're going to see where exactly it stopped in the program. We can also see in the code the yellow arrow. Now, if we wanted to, we could expand our bottom panel if that's where you have your autos or locals, and we can flip between the two tabs and kind of see the different versions. So with autos, it is going to be the closest variables to where the point is, or objects or variables. So we're currently working with first name and last name around this breakpoint. And we can see that they have no value, the empty strings. We can see their names, their values, and their types. We can also go over to locals, and we can see everything that we've made so far in project, or in project total. And we can see that converted age, I typed in 34, first name, last age, they have values of nothing. We have user age having the string value of 34. And we can see that X that I just made at the very bottom, and it has this negative nebulous number that we have not typed. It's just simply displaying that because we have not hit that point in the code yet. And then we see the types over here, again, the ints and strings. Now, if we wanted to continue, press the continue, the program will go on as normal. And then we hit the next breakpoint, which is just declaring and assigning or initializing an integer x to the value of 3. Nothing to display, nothing to execute besides creating that variable. We continue, the program ends. So utilizing the breakpoints is going to be very key to helping you identify issues with anything that you may have written or in the debugging portion of Lab 2. Because you'll have the variables and the values and the types available to you. Now, if I were to click step into, instead of continue, it's going to let me type in what appears to be the first name. And then we go back to halting the program, and we can see in red text the value change.
Okay, we're basically done with lecture 2.
Do we have any questions on breakpoints?
How
All right.
we finished lecture
So while I'm
3
thinking
and
about it,
4.
I'm going to disable these. So how I did that is I just hover over it, enable or disable, or you should be able to right-click it and delete, or I believe if you click it again, yeah, if you just single-click it, you'll also remove it as well. we're going to get rid of these. And we've seen a conversion here. The other thing that I was thinking about during slides was the actual toString method.
Concatenating.
This will take anything, for the most part, and convert it to a string. This is not always required. However, it will take a lot of ambiguity and possible issues if you are outputting like a lot of numeric types, because the stream wants a string type. If you happen to be like concatenating numeric values with string values that happen to be a numeric value just as a string, it might, depending, actually add them and display the sum of that addition. If you're not wanting that, and I recommend never doing that, is you would use the toString method. So in this case,
I need to take a look at this.
very basic example, where this right here isn't necessarily required, but if we were to do something like this,
let me out.
in some languages, they actually add in C++, I'm not sure, but we'll see here in a minute what it's actually going to do. So x is 3, this last line might show up as 5. It actually just didn't display. So, if we choose string it, we should now see 3 and then 3, 2, or 32. And now we can see it. So that is a use case for when you're using string literal values that happen to be numeric values with actual numbers. To remove any potential issue, use the toString method. It is going to be important as part of Lab 2. Now, speaking about Lab 2, we're actually going to look at that here in a minute, and we're going to break it down, how the output looks and what to go through and what to expect in labs moving forward. So give me a minute, I'm going to download a fresh copy of Lab 2. We're going to extract it, and then go from there. Okay, so when we're downloading labs from FSO, the first lab does not contain a project. The first lab is something that you're going to make. I highly encourage you to go through all the instructions that are on FSO for Lab 1. But for Lab 2 and forward, we actually provide the project for you to go through and finish. So Lab 2 section, make sure that you go through all of this, go through the video, go through the objectives and the outcomes. Under resources and downloads, we can actually see the downloads. So we're going to click that, and then some other things to take note of. This is going to be true for all the labs moving forward. Note this lab, well, specifically this portion, no. Lab 2 is the only one that has 2 sections or 2 parts to a lab. This is 2 different C++ solutions or projects. One is a debugging exercise, one is Lab 2. The debugging exercise is technically what we label as test 1 and 2, where Lab 2 portion project of it is going to be test 3 through 10. So the tests are effectively problems that we are providing to you to solve, and we'll see them here in a minute. Next is, prior to opening the program, you must first extract the zip file. So we have downloaded a zip file, and it's going to, by default, go into our downloads folder. So yours may look vastly different from mine because I have other projects and other files in here, but in the today section, we see Lab 2. We're going to, if we're on Windows 11, right-click Extract. If you're on Mac, you can just double-click. If you are using Visual Studio Code instead of Visual Studio, like regular Visual Studio. I know that there are some Mac students online. If you still need help with either setting up parallels, getting parallels, or even setting up Visual Studio Code, which is like the harder of the two, just let me know, or the harder of the three, please let me know. Send me a message on Discord. We'll get you set up. But for Windows, download the lab2.zip from FSO, go to your downloads folder or wherever you sent it, right-click it, extract. You'll get this little extraction wizard, and it's going to default to the directory that the zip file is in. So in this case, the downloads folder. It's my honest advice to not touch the path. If you touch the path, you're either going to send it somewhere you don't know, or you may generate a new path, and you also just might not know where that ends up being. So, again, we have our zip file, and press zip. Icon has vanilla folder with zipper, and then our extracted folder. Also, again, Lab 2 is the only lab that has 2 projects to it, the debugging portion and the conversions portion. So the first one we're going to look at is going to be debugging, and test 1, so the first problem is going to be inside of the actual project. Test 2 is going to be this Word doc. Open thing. Basically, what this document is going to go through is give you a bunch of stuff that it's going to ask you to do after you have completed test 1. You have to complete test 1 before you do this. It's going to ask you to utilize the breakpoints, the step into function, analyze the value, see what changed, and type it out. Just make sure that you go through all of these after you have done test 1. So know that it exists, because I get a lot of students that don't know that it exists. I want to make a mention of it before we go into the actual project. So for test 1, the debugging portion of Lab 2, once you open up the solution file, it might take a minute to load. It looks like it is on mine, but it is not going to actually open the project. Just as a reminder, this is one thing that can happen, and another thing that can happen is Solution Explorer is not viewable by default. So if you download your project and you see this and you're like, there's nothing here, there is, you don't have the panel to see it. So what you need to do first is go over to View, make sure that you click Solution Explorer if Solution Explorer is not visible. When it is, you can see the project name right here. You click this little arrow to see the directories in the project. We care about source files. So we see 2 files under source files. We see support. You don't have to worry about that. That's code that we've written to make sure everything that you've written is correct and good. Debugging is what you care about in this case. There's going to be a bunch of comments that are instructions for you to go through and fix. So if we look at this first one, there are 2 errors. There are 2 errors in the display user info method. So this right here, the variables used in the method do not match the parameters. These are parameters. So this is kind of day 3 material, but you have to understand kind of the structure of it. So right here, we have the declaration of the method, kind of like the main method that we've seen in Lab 1 or any of the demos. We have this void keyword, which we don't need to know about right now. We have the name of the method, display user info, and then parentheses, and a bunch of parameters. Right now, we can think of parameters as variables that are used inside of the method. We're just declaring them a little bit different. And what the instructions are saying is the variables used in the method, name and year, do not match the parameters of the method. Either update the variables being used to match the parameters, or update the parameters to match the variables that are being used. Because the errors that we're getting is identifier name is undefined, or identifier year is undefined. We're effectively using things that don't exist. You're going to get similar errors that you need to fix are out there. I think there are 5 total that need to be fixed as part of test 1, and you have to fix all of them before you can actually run the project and use the debugger and get all the info that you need for test 2, which is the debugging doc. So, going into lab 2, which is how all of the labs moving forward are going to look. So again, if our file does not immediately open, just go into Solution Explorer, go to, in this case, student_to-do. This is, for all intents and purposes, our source folder. What you want is going to be studentwork.h. In here, you're going to see a bunch of notes. Make sure you read all of them before continuing. So it says, please note, test 1 and test 2 are the debugging exercise of the project we just looked at, the doc file that we just looked at. Make sure that you do that before moving on to test 3 through 10. So you're also going to see the structure of a class called submission. Basically, it's where all the code that we've written for you to finish is going to be. You don't have to really worry anything about the class itself. All you have to really worry about are these methods labeled test 3, test 4, test 5, test 6, test 7, 8, 9, and 10. You're also going to note that there's a bunch of comments about each one. Those are going to be the instructions for the test method. So for test 3, your to-do, or what you need to do, is we give you a string input. You are to use the string to int method to convert the string to an integer. So what that means is this has a value at runtime. When we run the project, this will have a value. It does not look like it has a value right now because we're not assigning something. However, if I were to click the play button or the local Windows debugger and we get a pop-up for command prompt, we get a bunch of stuff. This stuff is also very important for you to go through the debugging process and to understand if what you have written is correct or not. Each section, so we're going to look at this set of equal signs, or our divider here with this set of dashes, our other divider. This is all of the output for test 3, right here. It obviously looks like that there's no output as part of that test 3 method. It's a bunch of background code that we have written so that you can see how you are doing, what your progress is for that method. Understanding the different columns is what we're going to talk about next. So you see this pass 1 of 5, 2 of 5, 3 of 5, 4 of 5. We are attempting your code 5 times. Denoted either with the word fail or pass, red text or green text, it's a fail or pass. If it's a pass, that attempt happened to be successful. Not all attempts will be successful unless your code is perfect. That's a strong word, but for most intents and purposes, there's a bunch of different ways to solve a problem. There's typically a absolute way to solve a problem. So if you solve it and you get like 4 passes and 1 fail, your solution that you selected to implement is not the absolute correct solution. And you'll note the points which coincide with the pass or fail. We attempt your code 5 times. It's out of 10 points, as there's 10 problems, or 10 tests in this project. So test 1, test 2 again being debugging, test 3 through 10 being in the lab 2 portion. Each test is worth 10% of the overall grade of the assignment. So 10 points for 10 problems. If you get like 4 passes and 1 fail, it's going to say 8 out of 10. To get points for the specific test, it has to have 5 passes. And even if it says 5 passes, I recommend testing your project 3 to 5 times, at least later on. And this one, it should be very cut and dry, where if what you have works, it works. If it doesn't, it doesn't for lab 2, but lab 3 forward, I would make sure that you test it multiple times, because sometimes there could be false flags for working. Also, in later labs, I think it starts in 3, since these are randomly generated values that we're working with, sometimes you will get an immediate false flag of a pass, and sometimes it will be all 5 passing. And if you don't write anything, that's not the solution. It just happened to be randomly generated corrects. So moving on to the next thing, right here where it says input. So we have our parameter or our variable that we're using for test 3, string input. This is its value on each attempt. Now, when I go through and close this and reopen it, take note of a couple of them, -10, -2, -5, and they're string values because they're denoted in quotes. We're going to rerun it. Bring it back up, over to test 3. We now have 1, -9, -4. Not the same values, they are randomly generated, so you can't account for the first 5 that you see. But also, to drive it home, in the code that you're writing and that you're seeing, they don't have values. But when the program gets run, our background stuff assigns randomly generated stuff. So you can't account for like an actual number. It always has to be randomly generated, or accounted for as randomly generated. So there is no accounting for specifically 1 or -9 or -4. Next is effectively going to be the answer, the expected output. So this is what we are expecting, and this is what we are currently receiving. So the 4th column, if we're counting the fail or pass text as a column, this expected output is what we are looking for as your answer, and the received output is what you are providing as an answer. So currently, it is 0. The reason it is 0 is because we're returning scope braces. So if I change that to 1 and we rerun it, we can see that the received output is now 1. In the context of PG1, you can think of a return statement as you are fill in your answer portion of a lab. There's a lot more that goes into a return statement that we'll talk about lecture 3 and beyond, but just know that whatever you have in the return, so if I say int x equals 6 and I return x, all the received output is then going to be 6. So just keep that in mind. And all labs moving forward are going to have this very similar output structure. So you'll be able to utilize like, hey, my received output isn't what I expected and it obviously doesn't match the expected. What do I need to go fix? Type of like mentality of how you use this to go and look at either further debugging with breakpoints or looking at the code that you have and rewriting. Some notes from online. Doug, the primary course director, usually has people create a full-scale folder and a PG1 folder. I can go through a demo of that real quick, and the reason that he has people make that is if you download the lab multiple times for whatever reason, like say you break something catastrophically, which does happen from time to time, my honest advice at that point is go download another copy of the lab and just retry it 1 test at a time. And then if you do not delete the catastrophically broken project, you then have multiple lab 2s. If you turn in the wrong one, you turn in the wrong one, and it's a bad time for everyone. So the reason why Doug has people make a new set of folders is so that you can drag and drop the projects after you download them and you know exactly where they are. That's for a meticulous, organized way to do it. That's what I recommend. What I do when I was a student is I typically didn't utilize the download folder for anything but full-scale projects on my student laptop. So it's your solution, whatever you want to do, is if you want to be lazy, leave it in the downloads folder and be susceptible to potentially downloading multiple having something break, turning in the wrong one, or being organized that way. And basically, I'll show that right now. Go to the desktop. You can right-click it, new folder, and then FS. I think it's jumped over to my laptop screen real quick. Yeah, it did. Inside of Full Sail, we can create a new folder called PG1. And then anything that you download, so we go over to downloads, we can take that zip, throw it in PG1, extract it there. Assuming we've done none of the work or progress that we have done so far in the project, we extract it there, and that's where all of our work would live. So in my examples, I usually leave everything in downloads, but if you want to organize it and not be susceptible to any type of confusion or turn in the wrong file, I would recommend a download or make a new folder for Full Sail and then making one per class. So we have the lab2 zip and the lab2 extracted inside of PG1, inside the folder, inside of our desktop. Also, it's good to note, because I just saw the icon, do not utilize, what do they call it, Microsoft Cloud. If you turn in a project from the cloud storage, 95% of the time it breaks when I get it. So make sure you are saving all of your projects locally on your machine, not in the cloud, and that you are uploading them from your machine and not the cloud. Say again? Yeah, you can copy them onto the cloud, but when you go to upload, just make sure you're pulling from a local drive. Yeah. What were you saying? Yeah. I know I have it turned up. Yeah. I typically leave it alone. It annoyed me so badly on my desktop machine back at home that I had to completely remove the cloud. So just keep that in mind. To do that, it's not going to show over there. But if you go to the system pane to where the clock is, the arrow, just hover all the icons. Look for the one that says OneDrive, right-click, pause everything, or cancel. Yeah. It'll eat your bandwidth. Yeah. Okay. Back over to the actual lab file and the output. So this lab, once you have solved one, you've pretty much solved the others. You just have to recognize the pattern. So you've seen me use string to int in today's demo. You've seen it in the slides. There are others that we recommend that you're looking up, like string to double, string to float, string to unsigned along, string to unsigned long, and then the toString, which is one of the last things I did in the demo. We also provide, I think, just on that last one, two on test 8 and on test, no, just test 8, 2 links to utilize outside resources that we recommend to research the methods. Same deal. You can basically Google C++ string to int, which I'll do right now, so you guys can have another example of that real quick. So Google it. If you have AI mode enabled for Google, which is by default, you'll get this. Don't look at this. This has a bunch of stuff that you don't want. It's just not usable for PG1 specifically. What I recommend looking at is C++.com, C++ reference, but I think that one is a little bit more legalese written. Definitely Geeks for Geeks, the one that we've been seeing so far. When we look at this, right here, there's at least one thing, at least in this syntax, this example, that's not usable in PG1. It's something that's already noted in the study guide on page 3 of 0.02 course overview. It's the size key. This just happens to be the declaration of string to int. It's us writing the method effectively, or whoever originally made string to int. This is their declaration. So that line we generally don't care about. If we scroll down, it's going to have a bunch of scenarios and a bunch of examples, a slight in-depth write-up of what it does, what it means, what it's for. If we scroll further down, it'll give you how it works, and it'll give you an actual example. So right here, you can basically see a base C++ console project that has IO stream and string. We have using namespace, the standard library, which we don't use in this course. And you're going to note that there's the lack of the prepend of std with scope operator. Because this is used, that's why you're not seeing the prepend. Again, this line right here, not usable for the course, but just know that why the reason you're not seeing the prepend on string, that's why. So inside the main, right here, we have string s equals geeks for geeks space 1. We have int n equaling string to int, passing in the s. And then we get the error text, basically the condensed error text of terminate call after throwing an instance of invalid argument, because geeks for geeks is not a numeric thing, it can't convert. So the first thing, and it probably explains it up here in these paragraphs, and probably a little bit below, of why it doesn't work. But if you continue scrolling, you're going to get some stuff that looks a little bit alien, if you're not used to hex or anything like that. So we have string str equals 2009 geeks for geeks underscore founded. We see a hex code and we see a binary code that's negative. We see a null pointer, which is not usable, and then we get some stuff like this. The things that we need to infer from this demo is the actual application of the method, or what we're looking for. So when you go and do outside research, even though I say geeks for geeks is fine, their examples will probably end up using external materials that aren't useful for the class. You have to be able to look at the example, and the easier one to look at right here is the one that errors out, which purposely errors out. But we now know why. It's because the string they made isn't a numeric value, it has words in it. So look for the easiest example, the shortest example typically, when you're doing your outside research, and go ahead and read like the paragraphs that you have. And same thing with stod or string to double. And for the online, made mention of a video from Doug that could use namespace. I believe that video just has not been updated. I can double check later on, but I'm fairly positive that the namespace cannot be used. Again, with string to double, we get the AI overview from Google. Has a bunch of stuff that we don't care about. It's effectively the declaration of the method. We see all of the links again, geeks for geeks, C++.com, and C++ reference. We're going to look at the middle one now. It's broken up, at least for my preference, and easier to read. There's a lack of ads. There's only one on the bottom. And it's broken up into sections that are denoted via lines. My personal preference. That's just me. You could like geeks for geeks better. You might even like Microsoft does, which we can look at later. So we get small sentences of what it does, what the parameters mean, and the return value. And then we get an example of how to use it. So right here includes IO stream, includes string. We have string orbits with 2 values inside of it. My screen clicking for something. We we have a string called size type. This is, yeah, it's an alias of size C, so this line isn't even usable. But the thing that we care about is effectively right here, the highlighted section. We don't care about the and SD, that's external stuff. All of these methods, like string to int, string to double, string to unsigned long, they all operate the same way. You are taking some string, putting it in parentheses, and assigning that value to the targeted type. So in this case, string to long, or string to double, you're taking a string value, you're putting it inside the parentheses for the string to double method, and you're assigning some double variable that converted value. Same thing for string to long, string to int, same thing like that. So just basically know that when you're using outside resources, a lot of them provide really good information. They're also just providing all sorts of stuff that's not useful, of course. You're going to have to basically make note of, hey, did I see this? Yes or no. Okay, so the other way, the other thing that I'm going to talk about before I let you all go, is there are different things that you can do to solve these tests. Either way is perfectly acceptable. So when we're looking at these test methods, to break apart the declaration of a method, especially the test methods, all of them, at least for this lab, are going to have a type associated with it. It's called a return type. We get into it on day 3. So int is the type for test 3. We also have the context of the instructions above it. We provide you a string input. We want you to convert it and return the converted value for whatever it happens to be. So the reason I make mention of this type is it is easier to understand what's going on if you create what's called a placeholder variable, at least in the context of this course, and utilize that variable to hold whatever you're doing. So in this case, we have an int method test 3, and I have an int x. So what I recommend you do is whenever you have a test method that has a return type, look at the type, make a variable inside of the scope of that method that shares the type, and name it result or work, whatever, basically whatever you want, as long as it's in proper naming conventions, and then return that variable after you do whatever your goal is to do with that variable. In this case, it's to convert the given string to an int. We would store that int inside of our int result, and we would return that int. I'm not going to do that last little bit because that's basically the answer, but you have the example of in the live demo and looking it up on Google, either through Geeks or Geeks, tutorials point, C++, etc. If question from online is can't find the study guide, so I'm going to pop back over to FSO preview. It's going to be in Introduction to PG1. It's going to be in course overview, so 2.02, and it should be right here. If for whatever reason you don't see the videos, you don't see the downloads, you don't see any of the PDFs, the typical reason for that is you logged into like your Xbox Live account, it's the Microsoft account, and it's basically using that as permissions instead of your full-scale email. You basically have to log out of your other Microsoft account or your Xbox Live account and log into your school email through FSO, like in this portion. Like if this showed as a gray box and said you don't have permissions, there'd be a login button or a logout button. Basically log out, log back into a proper account. You should be able to see it. This is the study guide that I'm referring to. Highly recommend going through it. Like I said, go through quite literally everything. On page 3 is the external resource policy, which is kind of what I've been talking about the entire time, like know what you use, what not to use. It's going to include a non-inclusive list of what not to use, because if we provided you an inclusive list, it would basically be enough. General rule of thumb, if you have not seen it, and I have not said, or if you have not seen it and I have said this is not good for use, don't use it. So in this case, auto size T, which is what we saw on one of the examples, null terminators, resize, ignore, clear, static cast, reinterpret cast, dynamic cast, all of those are a non-inclusive list of what not to use. All right, so do we have any questions on anything in the live demo, anything as part of understanding the lab and the output of the lab? If not, be back for campus students, be back at 5:30 for your lab. I'll leave it open for about like 5-10 minutes for online students to ask any questions. I'll throw my Discord username in chat again, just in case you might think of something later on. But again, I'll be here for like 5 to 10 minutes if somebody does ask a question.
And you said the lab is at 5:30?
For campus students, lab is at 5:30. Double check PG1 announcements for open.
Okay, awesome. Thank you.
Yep. Yep.
Does that mean we're done with lecture 2? Again? There's no reason to come back to lecture 2. We have everything that we need, essentially. Now it's just lecture 3 and 4.
Like the Discord campus signature, that's really good. Okay, so for that, I will reshare my screen. Screen 2.
And lab 4.
Make sure the right thing. Okay, for Discord, if you are not already verified, what you're going to have to do is go through, let's see, 100% go through 0.07, 0.08, and 0.09. Somewhere in here in the quiz, there's the button to join, and then in 0.09, I believe, there's also instructions for Discord, or there used to be. Okay, so I did get moved to 0.08. Go through that. Also, look at the lecture 1 recording. One of the early slides is, and lab 1 set 2, thank you. One of the early slides has the URL or a QR code for you to scan. one moment for the books. I think they tend to change sometimes, so let me double check.
What are we at? 252. And
Okay, so for the O'Reilly books, I think it's only if they're specifically mentioned in any videos. Double check all the research assignments for O'Reilly. And if you want to go through the book, I do encourage you to go through it. They just be mentioned in the video or in the text specifically if there's a specific book that you're looking for. But if you want to just like go through like generic C++ C# content, just go to the library link that should be in the research assignments and look for books that have it.
moving on. Lecture 3, page 1.
If there are no other questions currently, I'm going to end today's session. I'm going to throw my Discord username once again in chat for people to have.
Okay.
So if you think of anything later on, just shoot me a message on Discord. I'll get back to you later today. And then you guys have a the rest of your day. I believe Friday is the 4th, so we might be picking up lecture 3 on the 7th. Just make sure you look at the calendar on Discord.
Alright, we'll take a look at Lab 4 after our break. You can do 2 returns and an if statement.